Hey, hello. Welcome back to class. I wish I was in the room with you. This is getting really stale as far as I'm concerned, staying at home. I hope to be back with you next week. I was hoping to be back this week, but I just wasn't quite ready to return. The do now. If you have not completed the do now, you probably should hit the stop button on this recording and try and make sure you get your answers on the do now before you continue to play. Okay, I'm assuming at this point, if the video is still playing, we're ready to check some answers. Number one, I don't see any parentheses, but I see exponents. And so I'll take care of the exponents. 2 to the fifth power is 32. 5 squared is 25. 3 to the first power is 3. Now, I don't see any multiplying or dividing, so I can do the adding or subtracting from left to right. So I can do 32 subtract 25 to get 7. Add 3, I get 10. Hey, here's something a little bit new, and I really wish I was in the room with you for this. You're like, hey, what is with that square root symbol? Well, the square root symbol kind of works like a set of parentheses. It's a grouping symbol. And so we've actually got parentheses inside the square root symbol. So we have to work from the inside out, right? So we got to go inside and say, hey, inside the square root symbol, there are some parentheses. So let's go inside of those. Okay, so I see a 7 plus 3. That'll get me a 10. And then in the other set of parentheses, I see an 8 plus 2, so that's also 10. So inside the square root symbol, well, there's nothing else to do in the parentheses. I don't see any exponents. Is there multiplying or dividing? Aha, there is. That's multiplication. That's 10 times 10. 10 times 10, of course, becomes 100. There's nothing else inside the square root symbol that I can do, so let's just take the square root of 100. And of course, that is 10. So that was a new neat little twist. Number 3, inside the parentheses, choice of exponent or addition. Let's do the exponent first. 5 squared is 25. Inside the parentheses, the only thing left is adding, so let's add. 25 plus 13 is 38. There's nothing else inside the parentheses that we can do. And I wish I was in the classroom for this, because I'm sure some of you want to ask me a question or point out a shortcut. I'm sure some of you are like, Mr. U, when I first looked at it, it's like, yeah, I know, but we're not all ready for that. But yeah, 38 to the 0 power, of course, is 1. So I showed some step-by-step work there, but some of you that are getting really comfortable with this are thinking like, Mr. U, I could have taught you something on this one, man. It's like, yeah, if you see it, you see it. We'll definitely want to talk about that when I get back next week. Number 4, holy cow, inside the parentheses first, a bunch of exponents to take care of. 13 to the 0 power is 1, right? Anything to the 0 power has to be 1. 1 to the 8th power. Well, let's see, 1 times 1 is 1. Times 1, it's 1. Times 1, it's 1, right? I can keep multiplying by the number 1 all day, and it's going to stay 1. Right? So anytime the exponent is 0, the value is 1. And then 1 raised to any exponent is going to be 1. So if I just do 1 times 1 times 1 times 1 times 1, it's going to stay 1. And then 3 to the first power, of course, is just going to be 3. 3 squared, 3 times 3 makes 9. 2 squared, 2 times 2 makes 4. Inside the parentheses, I can go from left to right. So 1 take away 1 is 0. The plus 3 will sit there for a moment. 9 take away 4 is 5. So inside the parentheses, I still got to deal with a 0 plus 3. That'll be 3. Finally, 3 times 5, 15. fraction, I got to treat the top separately from the bottom. So 9 squared minus 1, I'll do the exponent before the subtracting. All right, 9 times 9 made 81. On the bottom, I got to do inside the parentheses first. 7 take away 3 is 4. Now on top, I can do 81 take away 1, which is 80. On the bottom, I can do 5 times 4, which is 20. Again, if you're a little kid in elementary school, you'll see a fraction. If you're a big kid, maybe you're in high school or college, you're like, no, that's not a fraction, that's division. Right? You're kind of middle, right? 7th grade, you're halfway between elementary school and high school. You're kind of still getting used to the idea that if we see a fraction, we can immediately think, no, Triton. We can immediately think that it's division. Oh, rough yourself. Inside parentheses, we'll do the exponent before the subtraction. 6 times 6 is 36. 36 take away 6 is 30. Now, you should be able to do this one in your head, because 3 times 3 is 9, so 30 times 30 would be 900. Okay, percents. I think everything that I'm covering today should be like old news, but I'm going to teach it as if it's brand new because some of us might need to have our memories jogged. So for this unit in the curriculum, we're supposed to be working with percents, but we're supposed to be doing things with like change of value with percents. But we're going to start out just by doing some of the preliminary review first. Okay, he's got a treat. He'll be quiet now. Okay. Now, per means like for every, and cent means 100. So when you see percent, we're talking about for every 100, right? Oh, I just bounced to the next slide real quick. Sorry about that. So percent means per 100. Okay, make sure you got this paper out in front of you. It could very well just be on the back side of the do now. If you don't have this in front of you, stop the video and make sure you get this in front of you before proceeding. Okay, let's complete this table. Fraction. I'm going to give you a fraction here. Your friend and mine, 1/2. You convert that to a decimal. Well, got to remember the number on top gets to wear the hat. I think they can do like a cowboy hat here or something. A nice, fancy-looking cowboy hat. Ooh. Number on the bottom, you get to wear those shoes. Remember these tricks here? The little Nike swoosh on that shoe. Okay, so I got some shoes down there. So if number on top gets to wear the hat, the one gets to wear the hat. Those dirty shoes, leave them outside, right? You've been hanging out with your friendly cows and you might have stepped in something you don't want in the house, so let's leave that 2 outside. Looks like I'm going to add a decimal and a 0 because 2 will not divide into 1. 2 times 5 makes 10. Aha, I get 0.5. Now, you could have also just grabbed a calculator and with a calculator gone 1 divided by 2, hit the equals button, and the calculator is going to say 0.5. right? Some of you might have that memorized, that 1/2 is 0.5. Some of you are like, hey, give me pencil and paper and I'll figure it out. Some of you are like, nah, just hand me a calculator. I'll do 1 divided by 2. Right? Again, little kid's going to see a fraction. Big kid's going to say, hey, that's division. That's 1 divided by 2. So that's where that 0.5 is coming from. Do-do-do, 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 my beautiful artistic stuff can go away now. Okay, now, that's a percent. Remember, percent for every 100. 100, we got to move that decimal 2 places. So I got to move the decimal behind the 5. Oh, that's only 1 place. So I have to add a 0. So 1/2, also known as 0.5, is 50%. Right? If you have half of something, you have 50% of it. Let's get another fraction up here. 1/4. Again, I can use pencil and paper. You might have this one memorized, or you can pick up a calculator and punch in 1 divided by 4. What do you get if you do 1 divided by 4 in a calculator? Yeah, you get 0.25. So the decimal 0.25 is the same value as the fraction 1/4. Now, if I want that written as a percent, got to move the decimal 2 places, right? Percent for every 100. So 0.25 is 25%. Right? If you got 1/4 of something, you've got 25% of it. Let's get another fraction up here. 3/5. Again, grab a calculator. 3 divided by 5 equals. And what does that calculator tell us for 3 divided by 5? Hopefully you've got 0.6. If you want a percent, we got to move the decimal 2 places. So I got to move it past the 6. Oh, that's only 1 place. So I got to add a 0. Right? If I'm thinking about 0.6, well, I should be an artist, huh? If I want to move that decimal 2 places, I can move it 1 spot behind the 6, but then I'll have to add a 0 so I can move a second spot. So that's why it becomes 60, right? Because the decimal's behind the 0. Now, notice that we never show the decimal when it's at the end, right? So we'll just write 60. That's why I just got a 60. And then, of course, because I moved the decimal 2 spots, I got to put the percent symbol. Notice the percent symbol kind of looks like a scrambled up 100, right? Percent for every 100 or per 100. Do, do, do. Do, do, do. Ow, nice and clean now. Hey, let's get another fraction up here. This is getting fun. 9/10. Well, the neat thing about 9/10 is I can look at that and also say 9/10, right? I mean, when I say 9/10, it could be the fraction 9/10, or it could be the decimal 0.9, right? Those are both 9/10. And of course, that'll be 90%. 7/8. Here comes the first really interesting one. Because if you grab a calculator and you do 7 divided by 8, you get 0.875. You're like, whoa, wait a minute here. Three places? I thought percent, I'm only supposed to move the decimal 2 places. That's correct. So we're going to move the decimal 2 places. So we'll move it past the 8 and past the 7. We'll have 87.5%. Don't round it off. That's an exact value, right? We don't want to round it off. We want to leave it exact. 87.5%. Now, what if I wanted to go the opposite direction? On your assignment today, I'm going to actually have you start with the fraction. You can then use a calculator to make the decimal, and then you can rewrite it as a percent. But I want to kind of drive this home that we can go and start with any one of them, right? We could start with the fraction or the decimal or the percent and complete the table. So let's start out with the percent, and this will reinforce how we go back and forth between percents and decimals, and this will also reinforce how we go between decimals and fractions. So what if I have 75%? What does that mean? Well, if I want a decimal, I'm going to move it 2 places. Now, I don't see a decimal point, so that means it's behind the 5, right? Technically, it's 75, and then there's a point. So if I move the decimal 2 spots, 1, 2, it needs to be in front of the 7. Oh, that's not erasing. Oh well. So I'm going to have 0.75. You're like, whoa, where'd that 0 come from? Okay, mathematicians have agreed that we're not going to start a number with a decimal point because it's really easy to overlook it and not see it. So instead of just putting 0.75, we'll put a 0 in front of that decimal. Now, how on earth do you make a fraction out of this? Well, I see a 75, and there are 2 places behind the decimal, and 2 zeros, right? That is 75 hundredths. There it is as a fraction. Of course, 75 is actually 25 times 3. One hundred is 25 times 4. We can cancel those 25s, and we end up with 3/4. All right? So 75%, also known as 0.75, also known as 3/4. Right? 75 over 100 is what that decimal actually means. But then I want to reduce the fraction. How come it's not erasing? Oh, there. Oh, I didn't erase before. Oh, one of these days I'll learn how to use this technology. Hey, let's get another percent up here. 40%. 0.4. Notice I didn't keep the 0 behind the 4. I don't need extra zeros at the end there. So 40% is 0.4. Right? As a comparison, think about how 0.6 goes with 60%. And that might make it more clear why 0.4 goes with 40%. And of course, that means I would have the fraction 4 over 10. But I'm not going to put 4 over 10. I'm going to reduce it. Right? 4 over 10 reduces to 2/5. Next percent. 2%. Some of you might be drinking 2% milk if that's what you buy at the grocery store. In other words, 0.02, right? That's what 2% looks like if I write it with as a decimal instead of with the percent symbol. So the fraction is going to be 2 over 100. But of course, we've got to reduce it. 22.5%. Well, let's move the decimal 2 places. 0.25. Now, this is going to be a real fun one to reduce, right? Because we've got 225, and there's 3 digits behind the decimal, so I need 3 zeros. So we're looking at 225 over 1,000. And we got to reduce that fraction. Well, both numbers end with a 5 or a 0, so I know I can divide by 5. So I grab a calculator. 225 divided by 5. What's that? 45? And then I grab a calculator. 1,000 divided by 5. Oh, that'll be 200. So we reduced it a little bit. Hey, each of those numbers either ends with a 5 or a 0, so I know I can divide by 5. Grab a calculator. 45 divided by 5 is 9. Grab a calculator. 200 divided by 5 is 40. So now I've got 9 over 40. I know 9 is 3 times 3. But 40 divided by 3, let me grab a calculator. 40 divided by 3. Ooh, have you tried to do that with a calculator? 40 divided by 3? We get a really interesting looking repeating decimal. So that won't reduce. That's as far as that one goes. All right, because all I can think of with 9 is 3 times 3. 3 is not going to divide into 40. Right? If I think of 40 as being 2 times 20, 2 won't divide into 9. Or if I think of 40 as 5 times 8, 5 is not going to divide into 9. If I think of 40 as 4 times 10, 4 won't divide into 9. Right? So that's as low as that will go. 9 out of 40 is the same as 0.25, which is the same as 22.5%. You dying to see what the next percent is? I would hope so. 37.5%. Also known as 0.375, right? We just moved the decimal 2 spots. Remember to remove the percent symbol if we're converting to a decimal. Remember to add the percent symbol if we're going from decimal to percent. 375 over 1,000. Can you reduce that? Dun, 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 dun. I'll give you a hint. It's one of the eighths. All right? It'll be 3/8. Right? If you have 375 over 1,000, you can have a fun time reducing the fraction. It'll go all the way down to 3/8. Hey, now we got some cool questions here. Again, this should not be anything new, right? This should be some stuff that you probably did in, I don't know, 4th grade, 5th grade. But I'm going to attack it as if you've never seen it before, so I've got to get your brain up to speed here. Now, I can also use this proportion. Remember, we've done a little bit of work with proportions. Proportion is a fancy word for ratio equals ratio. And ratio is a fancy word for fraction. So when I talk about a proportion, I'm looking at a fraction equals to another fraction. Notice I put is over of, and I put per over 100, right? Percent is per 100. And if you don't remember, if you put is or of on top, it's alphabetical. Alphabetically, is comes before of. is over of equals per 100. Now, how does this help me answer the question? Well, I'm always going to have that 100 is. Let's look at the question. What is? I'm looking for the is. I'll call that mystery number n. Notice I'm not using mystery number x because we're going to do some cross multiplying. I don't want to confuse that variable x with any kind of multiplying. So I'm using mystery number n. Keep reading the question. 45%. That means 45 over 100. Of 60. Of gets replaced with 60. Now we have a proportion we can solve. Remember how to do these? Cross multiply. N is across from 100, so I can do 100 times n. 60 is across from 45, so I can do 60 times 45. Time to grab a calculator. 60 times 45. Certainly not something you're going to be able to do in your head. At least most of us are not going to do that in our head, right? Pencil and paper would be kind of slow also. I'd grab a calculator. 60 times 45, you get 2,700. Of course, I just want n. I don't want 100 of them, right? I look at and I see 100 times n. Well, what's the opposite of times? Divide, right? The opposite of multiplying by 100 is dividing by 100. Notice I'm not trying to undo the number. I'm trying to undo the operation. I'm doing the opposite operation. If you need to use a calculator, go for it. Or you might have said, hey, if I'm dividing by 100, I just lop off 2 zeros. So our answer is 27. 27 is 45% of 60. Now, with this next question, we're looking for a different piece. We're looking for the of. But I'm going to start out with the same proportion. Is over of equals per 100. And of course, that 100 is always going to be there. Oh, I mouse slip here. All right, so 28 is my is. 70% will get me 70 over 100 of what number? So of is what? So there's our mystery number n.
You can pause.
Right, so let's cross multiply. 70 times n equals 28 times 100. Grab a really cool calculator, 28 times 100. Again, we want to undo the operation. Opposite of dividing, multiplying is dividing. And I'll come up with 40. Let's try to get through this next example without having me slip with the mouse here. All right. 57 is what percent of 60? Again, start with the same proportion. Is over of equals per 100. 57 is. So my is gets replaced with the 57. What percent? I don't know the percent. Mystery number n goes over the 100. Of 60, of gets replaced by 60. Solve the proportion. Cross multiply. 60 times n, 57 times 100. Grab a calculator if necessary. Although 57 times 100 might be something you do in your head, but I doubt anyone is going to do 5,700 divided by 60 in their head or with pencil and paper, right? You're going to definitely want a calculator now. Comes out as 95. Time for some independent practice. Have fun with it. Hope to see you on the flip side.